Margetts. I'm a professor at the Oxford Internet Institute at the University of Oxford. But I also direct the public policy program of the Alan Turing Institute. And this is the part of the Turing which was really set up to answer this very question. That we have been focused on that question for 5 years, really, thinking about what these technologies can actually do for policymakers. We launched the public policy program in 2018. And we were really thinking that what we wanted to do, we wanted there to be part of the Turing Institute that was dedicated to developing data science and AI from a public sector perspective. Most AI is developed by the private sector and often for the private sector. We wanted to look at it a bit the other way around, right from the start. So I proposed that to the leadership of the Turing back in 2018, and they were delighted to say that they were enthusiastic about the idea. And I was allowed to appoint one person, and that was Cosmina Dorobantu, who is the co-director of the program. And so we had the task. We just didn't have a very big team, just the two of us there at the beginning. And gradually, we did more and more work. We talked to more and more people in government. We built more relationships. We did more research. We built that research with policymakers in mind, and gradually the program grew. Just like that, those are right, okay? That's how it grew. I like to think that that grew in a coherent and incremental and a sustainable way. So that's where we are now. We have about 55 people, a great many affiliated researchers, but relationships with a key sort of 40 researchers working on over 90 projects with 20 universities, more than 20 universities. And we've had relationships with at least 100 public sector organizations, ranging from just kind of one-off things to things that look more like strategic partnerships. And these are the challenges we set ourselves right at the beginning. We went all the way around government, talking to people, trying to ask what are the kind of policy problems that you think these technologies might help with, and how can we help you to do it? And these were the 4 challenges that really kept coming up. First one, the first 2 actually, about sort of AI for governance. How can we do better government, make better decisions, and so on with AI and data science? Use data science and AI to inform policy making, actual decision making, make better decisions, evidence-based decisions, and so on. Then how to improve the provision of public services with these technologies. And then moving on to 2 challenges which are about the governance of AI. How you build the ethical foundations for the use of data science and AI in policy making, because lots of the questions that people were asking us, we were quite surprised, were about, they were the should questions. We'd like to do this, but should we do that? And we wanted to make a sort of enabling framework for that. And finally, contributing to the policy that governs the use of data science and AI right out in the wider economy and society, which obviously by now is a key issue that everyone's familiar with. So there we are. I'll start with the first. And this was really about building the kind of data science models which we wish there'd been during the pandemic, that we wish were available. And these are the sort of models that can cope with the things that characterize society today, really, that characterize the sort of problems we were facing during the pandemic. One is complexity, global supply chains, for example, the incredible complexity of modern life. That's very difficult to encapsulate in a model. Interconnectedness. We became very used to, during the pandemic, to sectors sort of bleeding into each other, the economy, the question of education and whether we close schools, the state of public healthcare and other public services, all of which were affected by the pandemic. And of course, that's a global issue right across the world. So the question of interconnectedness. And then finally, uncertainty. Every model has uncertainty built into it. But what when you're stacking models on top of each other? How does uncertainty stack up? These are all things, incidentally, that the human brain is not brilliant at coping with. We find it difficult to understand complexity and complex situations. Interconnectedness is not something that we're really good at thinking about. once you get beyond a certain number of connections. And uncertainty in our decisions, for example. If you're making several decisions dependent on each other, how does uncertainty stack up? So that is something we really wanted to think about. We now have a modeling for policy team. That's part of the slide I first showed you. And we're looking right across all these things. We're looking at production networks, and Hardik is going to talk about that in a second, working with what was the Department for Business, Energy and Industrial Strategy. Well, and is still, but has a different composition now. We're working on labour flow networks and interdependencies and what policies might look like. What if you were going to institute a policy like a furlough scheme? You know, what kind of effect would it have? Can you build a model that allows you to test that before you put it in practice? That's with the Department for International Trade. Sorry, the next one is about the internet. And we're working with the Department for International Trade, looking at questions of supply chains and so on. Housing markets, looking at inequality in housing markets, a really crucial question. Corporate networks and taxation. And finally, questions of policy prioritization. How can we work out where countries that want to achieve certain aims, like developing countries wanting to achieve the Sustainable Development Goals, for example, where should they put their limited resources? Where should they concentrate resources in order to best optimize their chances of reaching those goals? So that's our work on modeling for policy, or some of it anyway. And I'll pass to Hardik to talk about production networks.
Yeah.
And I'll pass you the remote as well.
Yeah, so hi, my name is Hardik. I'm also a research associate at Turing. And I come from a very physics and complex systems background. And I've been part of Turing for the last year and a half and more, working on problems that are relevant to public policy. And first, I'll try to break this term down of complexity science and what is a complex system. It's anything that has many interacting parts and behaves in a way that has whole which is greater than the sum of its parts. And I'll start with a very cliched image among complexity scientists of these starlings. As you can see, like every bird does something interesting, but as a whole, if you look at them, they seem to form these images and patterns that are pleasing to the eye. But imagine for a second if you're just looking at one bird in this flock of birds and are not able to see anything else, you would be on phone calling animal aid that this bird has gone crazy. It's moving in different directions. I don't know what it's doing. But as long as you look at the whole picture, it makes sense what these birds are up to. And this is what a problem that we can enter when we are working with data science, that we are standing too close to the trees. And we sometimes lose the picture of the whole, and that can lead us into a lot of different conclusions that are not very fruitful in some sense. And one of the signature of what the whole is doing can be uncovered through by looking at the relationships between the parts and how they're interacting, how they're evolving, and that can give us an idea of what the whole system is doing together. And once we understand what the whole system is doing, we can basically understand what the part is doing much more. So how do we actually go about, as complexity scientists, studying this? There are many different ways. I'm not here to give an overview of all the different methods, but there's one idea that I would like to introduce to all of you, is that not all correlations are born equal among the parts of the system. And to understand this, let's focus on the modern invention of a mobile phone camera. And you all might be aware of this portrait effect or depth effect, depending on if you're an iPhone user or an Android user. You can take images and you can blur the background. And this technology was not accessible unless a few years ago. And that was essentially because we didn't have enough camera sensors on our phone. When we had only one camera lens, we could not get this information of depth in the image. And as long as we started getting two sensors, now we have two perspectives of looking at the same thing. And they add something extra that we get this information of depth in us. And that's one of the reasons why we have two eyes and we are able to navigate through the complexities of the world. And there's actually a very nice, interesting theory that helps us to quantify all of this, which comes from information theory. So if you have two inputs, X and Y, going into an output Z, Now, every input can have gives you some information about Z. So X gives me some information about Z, that's in the red. Y gives me some information about Z, that's in the yellow. And there will be some information that I can get from both of them. So that would be the shared information, which is in orange and redundant. But there's something extra that you get when you look at Z when you have access to both variables, X and Y. And that's the synergy, as the information theory people call it. And that's in blue. Now, in this case, the information that you get from each sensor about the color is redundant because you can see the color in both sensors. But depth is something that only appears when you have both of them together. And the interesting thing is that we can now quantify this, and if this actually helps in understanding anything. So this is some recent work by my colleagues from Cambridge and Imperial on the human brain. And they showed that if you look at brain regions which are associated with motor skills or sensory inputs, they have more redundant interactions with the rest of the brain. So there's multiple copies of information because that information is really crucial for the brain. So even if one part gets damaged, that information is still out there somewhere in the brain, and it will make its way where it needs to go. But the higher level regions, which are responsible for emotional processing and cognitive processing, they have a much more synergistic interaction because they have to combine all these inputs and create some novel experiences of, say, consciousness. And we were interested in, like, can we take this idea of synergy and redundancy and look at the economy in that sense? Because economic systems integrate various inputs. They manipulate them. They create novelty. They also respond to shocks and demands of the market and systems, and in a much more agile way, as does the brain. So there must be a parallel there. So what we looked at is we looked at industries taking inputs from other industries and producing output. And across different nations and different countries, we had 180 countries and 26 sectors of economy interacting with each other. So here you can see a network which is how different 26 sectors of the economy interact for the electrical and machinery industry of the UK. And here we can find that there's this cluster of industries that interact together in a much more synergistic way to produce the output. Now, why is this important? Because most often there's a lot of talk about investing in a particular sector of the economy to spur innovation, but there is no target of where to spend this money actually. And what this is telling us is what relationships between the other sectors of economy that you have to invest in to spur growth in a particular target industry. Because these industries and sectors don't appear in isolation. They interact with each other in order to fuel growth with each other. So now, does this actually make sense? Like, does this line up with what we already know about the economy? So what we found here was that there are other metrics of economic sophistication known as economic complexity indices, which are based on just trade, but they don't really know how this stuff is being made in a particular country. And what we find is that the synergy among the inputs correlates very well with these technological sophistication indices that you just get from trade networks. So it's validating some of the metrics that are already there that quantify how sophisticated your economy is. Secondly, we found something interesting, that the service sector or the tertiary sector plays a crucial role, just like the higher order regions of the brain, to facilitate synergy between different parts of the brain. So the synergy is higher among the tertiary sector and the rest of the sectors of the economy, and it's lower among the rest of the sectors of the economy as it would be on random. And finally, the most interesting bit that leads to some food for thought for policymakers is that the synergy and redundancy, if you look at every interaction between every industry across all the countries, we find this asymmetric positive correlation between synergy and redundancy. So synergy, as I already have talked about, deals with what novelty comes together when you bring two things together. But redundancy is about how substitutable these two inputs are. Can I just swap between them? And often there is this idea in the policy circles of increasing GDP growth rate, and which is a very well-known, so the economic complexity or the synergy among the inputs, as now we see it, has been a very good predictor of GDP growth rate, and that almost becomes the focus. But there's a flip side to it, that if you make your interactions more and more synergistic, your economy becomes more and more fragile, because if even one of the input goes away, that creative output you get from the collaboration of these inputs goes away. So you need to back that synergy up with enough redundant interactions in your system to spur growth. And like just giving an idea of long-term sustainable growth rather than creating fragile economies which are not able to respond to a supply chain shock. And yeah, I think I'll stop there. I hope it was interesting enough. And I would like to thank my collaborator, Omar, who I worked with. And if you have any questions about this, you can always reach out to me. I'll hand it back to Helen to take this journey forward.
Thanks, Hardik. That was great. Yeah, so I'm just going to say something about the second challenge, which was about improving the provision of public services. I mean, actually, public sectors all over the world have used some kind of digital technology for a very, very long time, since the 1950s in the case of the UK. But to actually use these technologies to improve the provision of public services is something that we really hope the latest generation of technologies might be able to meet. When we first started thinking about the program, we had to think quite carefully what it is that AI and data science can actually do for policymakers. I mean, what specific tasks that government needs to do are they good for? You need to break that question down a bit and think about what those things are. And Cosmina and I wrote a little article in Nature, sort of outlining what we thought they were in Nature magazine, if you want to take a look. And the key things are, I mean, measurement. That is something that data science and AI are sort of famous for. First of all, being able to detect things, to be able to classify things in different topics, whether something is hate speech or not, for example, is such a task. But there's all sorts of other things that you want to measure. And then prediction. That, after all, is what machine learning is really, really famous for, being able to do kind of predictive tasks, to predict risk, for example, to work out what the risk of something is, and to being able to act accordingly. And then finally, personalization is there. There's actually very little personalization in the public sector. We're used to it all the time. Almost every platform we use is personalized in some way. We are not used to seeing those things in the public sector. But we'll always leave it on there because there'll always be some sort of technological development or some kind of social innovation which will allow policymakers to make strides in personalization. And it could well be that the current huge surge of interest in large language models could be the answer there, perhaps, to personalization in services like education, for example. Far too early to say. But definitely something that we will be working on. Here are some of the things that we're working on, or just starting to work on. One is the question of measuring a measurement task of measuring the tree canopy cover in cities. Why do you want to do that? Because trees are a key way to improve air quality in cities, to reduce the temperature of cities. And that's a key thing that you might want to do if you tackle climate change at the kind of more local level. And we have a project there working with Bucks County Council. Using large language models, and I have to break it to you that this is not ChatGPT-4. We've been using large language models for a while for other things, and this is a potential new project with the Department for Transport, looking at how these models might be used to process very large heterogeneous sources of text data. Governments have all sorts of consultations all over the world. They ask lots of people, maybe experts or maybe the general public, to sort of comment and give responses. And in the case of expert consultations, for example, some very clever civil servant reads all these documents, and then, well, what next? Really hard thing for the human brain to think, what does all this tell me, and how might it guide how I act? So we're really interested in how that project works out. Another project, similar version, but a more academic one, working with LSE on kind of conversational democracy. Can you ask citizens for responses which are easy to give and then process large amounts of, large quantities of responses. Same might be done for complaints, for example. Almost every agency in the country has some sort of complaint system, actually all of them completely different, unfortunately. But how might you think about using these technologies to actually process from complaints what's actually going wrong? And also, of course, to use some of the other things I was talking about, like predictive capability to say, what's the next failing school or failing hospital waiting to happen? Another project on natural language processing to process case notes, for example, with the Ministry of Justice. And again, huge scope to process large, heterogeneous sources of data, something that humans aren't really very good at, if we're honest. And then finally, looking at this is a joint project with the health program, looking at clinical adoption and acceptance of AI tools. And I will now hand to Cosmina to talk about the next challenge.
Super. Hi, I'm Cosmina Dorobantu. I'm the co-director of the Public Policy Program at the Turing, and it's my pleasure to take you today through our work on governing AI. And the first challenge that I want to talk to you about is building the ethical foundations for the use of those technologies in the public sector. Very early on, Helen said it was just the two of us in the program, but even back then when we're going to talk to policymakers, one of the most one of the questions that we got the most was not, how can I build this, but should I be building this? And the public sector is incidentally a very, very good place to start thinking about the ethics of those technologies. Because the public sector is the one bit of our world that is entrusted with looking after the public good. This is their job. And if you start thinking about those technologies from a public good perspective, it's much easier to sort of build your ethical framework around that. So when we think about ethics, and our largest team at the Institute is our team of ethicists, and that's the other thing that I would sort of want to bring to your attention today. How exciting of a time is this, that we can have ethicists in a public policy team? And I don't think we've ever been able to say that our team of ethicists were bigger than the team than the other teams, and they are involved in all of the decisions that we're making. And I think that's a brilliant thing about those technologies, and we don't think about maybe enough about sort of the cultural shift that we have just by bringing those people into our policy-making processes. But when we think about ethics and responsible innovation, we always start by thinking about the values. What is the common vocabulary that we can use to start to talk and to weigh up the benefits and the cost of a particular technology? We also think about principles, which are actionable bits and the guardrails that we set in practice for the use of those technologies. Then we think about the practice itself. It's great to have values, it's great to have principles, but what does that mean for a data scientist that's sitting down and trying to set up a project? Now, this is some of the work that we have been doing. We have written the UK government's official guidance on AI ethics, and it is now the most cited guidance in the world. It is in use throughout the public sector in the UK, and that was a joint project with the Office for AI and GDS. We've also written the world's first national guidance on AI explainability, and that was a highly exciting project with the Information Commissioner's Office, and it speaks, I think, to how innovative this country's regulators are and how well positioned they are to drive the global conversation on this. No other regulator in the world published similar guidance at the time this was published. We work on data justice work, and we work together with GPay on that, and that's an exciting project. We have some documentaries coming out. There's actually a stance downstairs on the 3rd floor if you want to go and check it out and learn more about that work. And we're also partners with the Council of Europe, who are now thinking of human rights-based approaches to AI, and they're thinking of building a first legislative instrument. We're partnering with UNESCO as well. There was a historical agreement in November 2021 when all UNESCO countries accepted some recommendations for the ethics of AI. And we're now working alongside UNESCO to understand what does that actually mean in practice, and how can we how can we make sure there's not just something that people say we agree, but they don't actually do? We're working with the Ministry of Justice, and this is a highly exciting project on building an ethical framework for the use of data science in the criminal justice system. And the reason it is exciting is that we've been able to talk not just to the people that use the technologies, but also to the judges and to the prisoners who are ultimately going to be most affected by this. What do they think about it? We have a new report that looks at inequity in medical devices and how the technologies that we're building are perpetuating sort of the systemic inequalities that we've had in our societies for a very long time. And I'm excited also about our work with UNICEF on creating the world's first AI ethics guidelines for children, because in our conversations about those technologies, we often forget that our children are very much interacting with them as well. And what does that mean for them, and what does consent mean for a young child? But none of this is possible unless we also look inside our own house and think, who is building those technologies? And one of the earliest projects that we started at the Turing was a project that would look at how we can bring more women into data science and AI. I'm very happy to have Judy Wiseman here with us, who leads this work, and I'll let her tell you about it.
Thank you very much. I'm Judy Wiseman. I lead the project on women in data science and artificial intelligence. And as Cosmina said, not only are ethics so foregrounded in public policy, but it's a wonderful thing that right at the beginning, actually, Helen and Cosmina said we can't be doing this without thinking about gender equity as being embedded in these kind of new developments. And I was lucky enough to be in the right place at the right time and come on board. And the aim of our project is really, as I said, to make sure that we research and have policy initiatives to embed gender equity into these new developments. And I'd like to begin by just saying how timely this is. I mean, in fact, UN Women, this International Women's Day, which as you know was just a few weeks ago, their theme this year was innovation and technology for achieving gender equality and empowering women and girls. I mean, it's just centrally on the agenda. And I was very happy yesterday there was a workshop here that was, incredibly well attended with a panel of women speaking about their experience of working in data science and AI, how attractive these careers were, and how they were trying to really encourage more people to be drawn in to this kind of work. Now, I have to say that the underrepresentation of women and, marginalised groups in STEM is not a new issue. This issue's been around for a very long time. But what really has concerned us is that these inequalities, if you like, this underrepresentation is being replicated in new areas of technology. I've been around this area for many decades. The problems are old problems, but what we're worried about is this kind of the repeat of this, even though the developments in technology are new. As someone who came in during the microelectronic revolution, I'm watching different technological revolutions and wondering how this replication occurs really and what we can do to stop it. And I mean, one reason we need to stop it is obviously that there's a skills gap. We hear all the time about the technical skills gap, and yet women's untapped, talents are really kind of still incredibly untapped. But more than that, and why I'm very happy that our project fits so squarely within our thinking about ethics and responsible innovation, is that I don't think you can have ethical AI or responsible innovation without embedding gender equity at its centre. My own research for many decades, as I've said, has been to show how the lack of diversity in the workforce, in the designers who make technologies, actually is directly linked to the kind of technologies that are developed, including the social biases that are now being increasingly kind of recognised as encoded in algorithms such as facial recognition and recruitment software. And in our work, we talk about this as a kind of feedback loop, that in a sense, if you feed in data based on an unequal society, these things are going to be replicated and maybe even amplified in this automated decision-making. We've spent a few months making a very short 3-minute video that we hope makes these things clear. I'm not a kind of very visual person myself, but I have lots of filmmaker friends in Melbourne who I showed this to recently, and they thought it was not a bad animation, actually. I had wanted to have some Miles Davis music, and they said to me, Jude, if you have Miles Davis music, people will listen to the music and not look at the images, so they all advised against that. So I hope you like it, and then I'll say a few words after I've shown it. Is this going to work?
Alexa, Cortana, Siri. Have you ever thought about how many of our AI voice assistants have such feminine names and voices? The gendering of digital helpers encourages stereotypes of women as domestic and subservient. Would a gender-neutral voice solve the problem, or are there more fundamental ways in which AI embeds inequality in its code? Is this why artificial intelligence is a feminist issue? We are the Women in Data Science and AI team, part of the public policy programme at the Alan Turing Institute, the UK's National Institute for Data Science and AI. We conduct data science and social science research through a multidisciplinary lens, exploring the ethical, economic, and governance-related issues stemming from the underrepresentation of women and marginalised groups in AI. We provide data-driven insights informing policy measures aimed at increasing equity in AI in the UK and globally. Bias can sneak into various stages of an AI's development, where inequalities in the world are built into seemingly neutral machine learning systems. As an example, let's consider AI as a hiring tool in the tech sector, where automation is increasingly used in recruitment. Machine learning systems are fed data to learn and predict outcomes. For hiring, data comes in the form of CVs. But what happens when the majority of CVs come from men in male-dominated industries? The algorithm is fed by historical discrimination, creating a feedback loop whereby new systems replicate old patterns. By being fed biased data, the machine learns to make biased decisions. Bias also creeps in via human design decisions around algorithm development, data labeling, and modeling, as the team developing these HR tools bring their own values, priorities, and assumptions into the process. AI systems are biased because they are human creations. If a member of the team had recognized that the CVs underrepresented diverse groups, then decisions to augment the data could have ensured more inclusive representation. Bias also enters the tool during its deployment. Fewer women apply to tech jobs, reflecting both the STEM talent pool and the culture of these workplaces. This reinforces the feedback loop whereby gender bias is built into the broader AI ecosystem of which the tool is a part. Gender, and other biases, are embedded in the foundations of all the technologies we interact with on a daily basis, from gendered streaming service viewing recommendations and ads, to potentially more harmful systems deciding who gets welfare approval, is charged with crimes, or is diagnosed with a disease. Algorithmic bias, like human bias, can result in unfair outcomes which spread quickly at a large scale. These biases are not a result of bad intentions, but rather to do with AI's fundamental structure. The path to just AI is a long one, because society is still a long way from equality. But the good news is that our project is part of a larger network that includes AI scientists, feminist scholars, and government and industry stakeholders who are working on solutions. These include increasing diversity in the tech industry, developing technical and non-technical bias mitigation methods, and building AI ethics and governance frameworks. It is crucial that we get ahead of this now, before flawed technologies become irreversibly integrated into the fabric of society. Our project promotes participatory and democratic practices of responsible, ethical, and fair AI design. Tech should work for everyone, and we have the opportunity to shape it for a better and more inclusive world.
Actually, to be completely honest, the one thing my friends did say, which shows my demographic, is where are the older women in this? You know, that's just one image that we didn't quite get. Anyway, just sort of quickly, and I hope the sort of animation has made these points. I mean, we really take a three-pronged approach to this issue, which I think of kind of simply as fixing the numbers, fixing the institutions, and fixing the technoscience. And what I want to really stress in my just very few minutes now is that these problems are interconnected, that we really can't fix one without fixing the other. I'm not going to say much about fixing the numbers, getting equal representation of people into this area, although I do want to say that I'm very, one of the things I've been critiquing for a very long time is this language of seeing the issue of kind of women in STEM as a pipeline issue. I think the problem with that kind of theorization, if you like, is that it very much puts the problem into the future. It very much sees the problem as one of individual women, rather than looking at institutions and structural issues and contextual issues that are creating these hurdles for a wider variety of people to engage with these technologies. And as we know, and I've written about for a very long time, part of the problem is the kind of image of what technical work is, and that was part of what the workshop yesterday was trying to encounter, the sort of images around technical work that somehow are related to masculinity. And I was very intrigued yesterday that some of the women were talking about simple, she says, hard to achieve, but straightforward things like better parental leave, maternity leave, childcare, working hours that are flexible, all the things we've been talking about for a long time are still really obstacles in these professions and very much need to be worked on. I have to say that I'm very optimistic about the institutions of education as opposed to the institutions of the workplace. I think there's lots of training schemes going on. There's lots of universities that have got fantastic access schemes at the moment that are transforming, that there are equal number of women and men doing computer science in lots of places now. Lots of progress in that area. I think what I think about as kind of organizational culture or workplace culture is being harder to shift. And even though there's a lot of discussion about kind of diversity in corporations and organizations, tech organizations, including the kind of big five, I don't think there's been much progress there. And one of the things we tried to do in the project, and I think is very important, is to be able to collect better data on what's really going on in terms of diversity in these companies. And I think there's a real kind of data gap in terms of that. And then finally, I can see you're looking at me, Cosmina, finally, quickly, there's the issue about why this matters, right? I mean, I've been asked for decades, why does it matter? Why does the underrepresentation of women matter in these areas? Well, I can tell you why I think it matters. Is because it matters in terms of the kind of technology we get, the kind of innovation we get, that actually the value and experiences as developers are bound to shape the kinds of technologies we get, the kinds of innovations we get. And maybe just to end by saying that some of these things are straightforward and easy to see, and we all know about Google search and the hackathons to get more women into Wikipedia. We all know about sort of Siri and the kind of images, the gendered images we have of kind of robotics. I think we're in a phase now where the problems are rather tougher in terms of having gender audits, in terms of the kind of data that's being used in a lot of the automated systems at the moment, and that we really have to kind of focus on those kinds of issues. And I'll come back later with these questions.
Super. Thank you so much, Judy. I could listen to Judy for a very long time, just for the record. Great. Look, I'll just take you through the last of our challenges, which is to contribute to policy that governs the use of data science and AI. And really what comes into this, there's a story about regulation and how can our regulatory systems cope with this new wave of technological innovation. I think there are very exciting developments here in the UK. I think it's right for the UK to take a sectoral-based approach. There are some horizontal challenges when it comes to regulation, but there are definitely sector-specific challenges. And we've done a fair bit of work at the Turing to try to understand how a sectoral-based approach could work and what would be needed to actually bring it to life. And standards come into it as well as tools that can help us in AI governance. Because standards can fill in where regulation cannot. And as part of the national AI strategy, there was a proposal to set up an AI standards hub, which is now at the Turing. That's an initiative that the Institute is leading on in partnership with BSI and MPL. There's a lot of excitement around that around that work, and please do check it out. There's a stand downstairs on the 3rd floor, and also, we have an AI Standards Hub website, lots of trainings available, lots of events. This is supposed to be an initiative that interacts and gets feedback from a lot of people, so please do get involved. One final thing I'm going to say about regulation is that there is a technical side to it as well. And this is something new for some of the country's regulators. So, for example, you cannot do online safety without looking at the technical side and understanding the technical side. And this is some of the work that we are doing on online safety here at the Turing. We have an entire team dedicated to it. We have an online harms observatory, for example, which is a world-leading real-time AI-powered dashboard to monitor online harms. That's a project in collaboration with what used to be the Department for Digital Culture, Media and Sport. I'll pick on just one other project from here, which is building and improving classifiers for online hate and abuse. And when you read that description, it sounds like a really technical project, but it's not just a technical project. Of course, you need the machine learning tools and experts to build that. But the question of what hate is not a technical question. That is a question that's very much grounded in the social sciences. And the final question of this project, once you build a classifier, once you've understood what hate means, what does it mean in practice and what does it mean for policy? And that's a public policy type question. So the project actually brings together specialists in machine learning, social sciences, and public policy to try to understand and work alongside Ofcom on how we can make our online spaces safer. So that's it. This is sort of the whirlwind tour through our program of work. The final thing that I want to say about the program, and we do go and present it a lot to international audiences, and a lot of countries are telling us why don't we have this? And the reason this is an amazing thing to have in this country is that it is a one-stop shop. We are the National Institute to access expertise on those domains. We do provide coherence, so a department that comes and asks us for advice in one area is going to get the same advice that we give to another department with the exact same question. We do have agility because, as Helen said, we're now a team of more than 55 researchers based at the Turing, ready to be deployed and work alongside policymakers to solve some of the challenges that we have seen today. We do multidisciplinary at scale, and I try to emphasize this a little bit as to why it is important to have the various disciplines in the room. This is not a one discipline approach. And finally, it's important for the government to have a trusted advisor where they can come and ask questions about those technologies. And I will stop there, not before thanking you for all of your attention, and we're happy to spend the next 10 minutes that we have together answering your questions.
Thank you so much. We do have some questions, and the latest question just came in is if we can have more time set aside, and unfortunately we cannot. There's a lot of really good questions on Slido that we can share with the speakers later on, but we only have time for a few of them. As Cosmina said, we only have about 10 minutes to do this. So I'll start with the most voted one. So how can the government nurture and retain data science and AI skills in the civil service? Who would like to answer this?
Well, I'll start anyway. Well, it's a really important question. I wrote my PhD about digital technology and government. It's always been this challenge, how can government get expertise, how can it match private sector pay grades, et cetera, et cetera. One thing that I would say that's really positive is that compared with the days when I wrote my thesis, which is obviously a long time ago, a very long time ago, there is so much more interest in it now. When I was first working on this, nobody was interested. Nobody in academia was interested, but nobody in government was interested. Absolutely nobody. And you certainly wouldn't have rocked up for this session. You would be off over there watching Boris Johnson's show trial. So, you know, there is a lot of interest in it. People recognize the possibility of these technologies. And they want things to happen. And it comes right from the top, you know, the question of how you can, you know, use machine learning for public services is in the national data strategy, digital strategy, AI strategy. You know, it's right in there. A sort of recognition that public sector problems are interesting as well as crucially important. So I do feel that these sort of technologies, and therefore the recognition of the need for these skills, has gone much closer to the heart of government than it ever has before. It's still going to be a challenge. It's still got to be prioritized. It's still got to be recognized that this is center stage, that it's not going to ruin your career getting involved with it like it used to for big technology projects, particularly in the UK. So, yeah, it's a challenge. I think we're more up to coping with it than we have before. And actually, the private sector, tech sector, is facing a lot of challenges right now. So there's a huge amount of talent out there, and what generally happens at times like this is that the public sector becomes the sort of attractive and innovative place to be. So I think we are at a hopeful moment from that perspective, at least.
Thank you. Would anyone like to add anything?
I'll add a few words just to say that at the Turing too, we compete with the private sector when hiring people. And I think there are two things that attract people. One is the possibility to work on incredibly difficult questions that are quite fundamental for humanity as a whole. And I think the second one is the ability to learn in this role and to grow in this role. And the public sector does have that going for it. It is home to some of humanity's most consequential questions, from climate change to social inequities. And I think those are the questions where those technologies can actually really help. I wish, we are seeing more expertise being built into government, and I think government absolutely needs to do that. You cannot, legislate over those technologies without understanding what they mean. And I think the days of outsourcing all of this to the private sector are gone. You do need specialists within government. But we are seeing a shift, and there certainly is a hype. And one of the presentations that we give has the slide at the beginning that shows the number of publications that mention government publications in this country that mention data science and AI. And it goes from sort of, like 5 publications in sort of like 2017 to hundreds and hundreds of publications now. And, the interest is matched with more talent being brought into the civil service. And at the Turing, we definitely have worked with some amazingly talented data scientists within the government. So, they exist, they are being recruited, and they're doing a wonderful job.
Thank you. Yeah.
If I could just say one more thing about that. I mean, we had a session on online safety this morning, and we had a speaker there from Ofcom who mentioned that they've recruited around 200 people now to kind of tool up and gear up for the online safety bill. So when priorities are put in legislation and right across the policy-making piece, it is possible, to attract people because as Cosmina just said, people recognise these questions as so important. So, yeah, it can be done. One challenge, of course, is that we so often think about AI as a way of saving money, of sort of cutting people and saving money. And that is a problem for government because that's very seductive. You get these technologies, and if you're going to get it right, I do think that these technologies have enormous potential to improve productivity in the public sector, for example, but only if we get it right and resource it properly. It can't automatically be a way of saving money. You need the expertise inside the organisation.
Thank you. I think you somehow answered a little bit of the latest question that came in as well regarding the challenge. I do want to ask something, which is, how do you see policy making around preventing AI competition dynamics that might lead to deploying AI faster with less security checks?
Do you want to? It's got the word, she's an economist. It's got the word competition in it. But
It does. I'm not sure I fully understand the question. It might just be me. Hardik, do you?
I mean, I guess it's much closer to asking that if there are new technologies being developed, should we have less regulation in it for the ability to lead in that sector and deploy it faster than other countries? And
yeah, I mean, it could be referring to the question of large language models, and we had ChatGPT-3, and then we got, or I think it's been launched today, hasn't it? Google's Bard who had originally said that they were going to do a lot more checks and ethical checks and things like that on it, but were sort of spurred by competition dynamics to release it sooner. I mean, that is a huge question. There are so many issues that have been brought to the surface by the release of sort of popularly available large language models. So, yeah, I mean, policy making has got to be agile. I mean, in fact, it's got to be agile to new technological developments, and I think this is a process that's been going on for a very long time. We saw it with the first sort of tranche of digital services in government. The government was lagging 20, 30 years behind the private sector in many countries. And, technology puts pressure on government to innovate, a sort of continual source of pressure on government to innovate. And that's not what government's generally been famous for. In fact, there are theories in political science, I'm a political scientist, of why government can't innovate. And we've got to get out of that mindset, really. Government can and does innovate, there can be policy innovation, and we've got to get that kind of innovation going in the regulatory sector in terms to keep up with development.
But I think, just going on to the next thing, I think the parallel with drugs is interesting, and I don't know the sort of answer to that question, right? But, I was really struck last week or whenever it was that, we had a new injection for obesity, that we've got this endless ongoing announcement of kind of new drugs. And yet I think there is a much more a community understanding that these things need to be tested properly, much more sort of cynicism about the pharmaceutical companies that were pushing this. There's whole issues about whether the NHS will take it up and whether it's private. I think the sort of, in the history that we've had of ethical government regulation around kind of bioethics, and, for me, the first thing was actually the committee on IVF, which was a big thing when I was kind of quite young. And I sort of think we could have, hopefully in the years to come, we'll have similar kind of, community knowledge and understanding and kind of will to discuss these developments and to see how we can kind of collectively, think about guardrails or, that speed isn't always the sort of main things, that we need to be kind of more careful and nuanced in the way we're kind of going to approach these things. So I don't think it's not an easy parallel with drugs, but I think it's kind of a useful kind of mental parallel to make, actually.
It's a really good point. I mean, there are so many issues in bioethics that we've been thinking about for such a long time. And if you look at the timeline of the kind of things we're talking about now, it feels like a long time, well, especially to us perhaps, but, it isn't really. It isn't such a long time that we've been talking about these things. And I don't think it's impossible.
I'd really like to answer the third question, though. Is that?
I was going to say, if you want to add.
I'm very happy to do that. I mean, I'm kind of very aware of this issue, and our project is very aware of this issue. If you look at any of our publications, you'll see that we're trying to do intersectional work, that we're very aware that women aren't uniform, that there are lots of different kinds of women and classes and ethnicities and all of these things. I mean, we have had a problem, like everyone has a problem, that if we're doing kind of data science and trying to do our research, we've literally got an empirical problem of the kind of representation and numbers in the data and what kind of analysis we can do. But we're very aware of this, and you know, all I can say is we're kind of doing our best to do more work that's more sensitive to intersectionality than we've managed kind of to date.
Thank you. There's unfortunately no more time.
Ah.
That was right on time. So can we have a round of applause to our wonderful panelists today?